Alright, tonight's video is looking at storms. We started looking at this in class today, and with your group you looked up one of the kinds of storms in a lot of detail. Tonight's notes are going to give you a quick overview of the four main types of storms. So let's get started. What is a storm? Alright, so storm is any violent disturbance in the atmosphere. So not just rain that comes when warm air gently rises, condenses, and the water vapor condenses and falls back to the earth. We're talking high winds, violent precipitation. That's what we're going to call a storm. So we're going to start with our first type of storms, which is a winter storm. In a winter storm, we get large amounts of snowfall, often with strong winds. Right? This will happen a lot of times when a continental polar air mass pushes down into a maritime polar or maritime tropical air mass and creates a strong cold front. We also get a lot of what's called lake effect snow. And this occurs when winds blow across warmer lakes and bring snow to the opposite sides of the lake. Right, so lake effect snow, we will see what happens is you have colder air moving across the lake, which is cold itself but warmer than the land. This lake adds heat and water vapor to the air mass as it moves across. It condenses, since we're on the cold other side, and we're going to get snow falling on the other side of the lake. So as you can see in this picture, right, the yellow and green colors represent areas that get lots of snowfall, and a lot of those are on the downwind side of these Great Lakes. Right, so you get lots of wind coming, in this case from west to east, pushed by those prevailing westerlies, comes across the lake, and then dumps lots of snow on the other side of the lake. Alright, our next type of storm is a thunderstorm. This is something that we're very familiar with here in Georgia. We get a lot of these, especially in the springtime. And a thunderstorm is just a small storm that's got heavy precipitation, thunder, and lightning. And this happens when warm air is forced upwards rapidly. Right? You'll remember from when we looked at fronts that this happens a lot in a cold front. Cold air, in this picture, cold air would be coming in from the left and pushes the warm air on the other side of the front up very quickly. And so it rises up super fast and forms this huge cumulonimbus cloud. Right? And you're going to get lots of rain coming down off of the bottom of that thunderstorm. And you can often get hail in these storms as well. Remember I said we would get to hail. Hail forms when convection currents in that thunderhead toss around ice particles around and around and around. So you get really strong winds in this thunderstorm, and these little ice particles get tossed around, and each time they take a loop through the cloud, they add on another layer of ice. So actually, if you cut open a hailstone, you can see, just like a tree ring, you'll have little ice layers. Sometimes they're hard to see without a microscope, but you can see basically how many times this hailstone has been tossed through the clouds. Eventually, it gets too large for the cloud to hold, and it falls to earth. Right? So the stronger the storm, the bigger these hailstones can get because it has stronger winds able to keep the hail aloft. If it's not a super strong storm, or if it's not cold enough in the clouds to form ice, you won't get hail from a thunderstorm. So not all thunderstorms form hail, but the stronger the storm, the more likely that is. And the last thing with thunderstorms, we'll just look at thunder and lightning quickly. So with these air motions, right, you've got all this warm air moving upward quickly. These cloud particles build up a static charge as they kind of rub against each other. Think about when you shuffle your feet on carpet, you build up a static charge. You've got lots of positive charges on one end of the cloud, negative charges on the other. That can result in some positive charges building up on the ground. And eventually that charge difference is so big that lightning sparks to even out the charge difference. Right? So you can get lightning from the cloud to the ground, which is what we tend to think of, but you can also have lightning within a cloud. It's the same basic thing as a static shock, except way, way, way bigger. And the heat from that lightning creates a pressure wave in the air that we hear as thunder. So that heat causes the air to really quickly expand and contract. And that creates a shock wave, and that we hear that as thunder. Alright, we're going to just quickly look at our last two types of storms. We've got hurricanes. Alright, so a hurricane is a very large, low pressure area that forms over tropical oceans. So you've got this area of very low pressure that forms, right? It's very warm over the water out there, so we will get areas of very low pressure. And as winds come into that low pressure area, you've got lots of evaporation over the water, adding lots of water vapor and energy to the storm. And so the longer it spends over those warm ocean waters, the stronger the storm will get. And you'll get high winds. To have a hurricane, it has to be over 119 kilometers an hour. Heavy rain, and when the storm hits land, a lot of times it will push ocean water in front of it, and we call that a storm surge. Hurricane season in North America is June to November, right? Which is when the Atlantic Ocean, the central Atlantic Ocean, is going to be the warmest and provide that energy to the storm, right? It lasts into November because water holds heat so much better than land does. And then our last type of storm is a tornado, all right? This happens usually with thunderstorms, especially stronger thunderstorms. It's caused by really rapidly rising warm air. So this warm air comes up so quickly that the air on the surface coming in to take its place ends up kind of spiraling around that area where the air is coming up so quickly. And so that cold front pushes under the warm air gets pushed up quickly, and it pushes up so fast that the air coming in to take its place ends up spiraling around and creating a small, very rapidly spinning cloud that's going to touch down. They usually last less than 15 minutes. They can be really narrow or they can be really wide. It just depends on the dynamics of the particular storm. And that is all we have with storms, right? 3 questions at the bottom. I'm sure we have some. We didn't go into a ton of detail on hurricanes and tornadoes, but your book has some good explanations. And there's tons of good resources online if this is something you're interested in and want to learn more about. I will see you guys in class tomorrow.